אומרים, יש לנו כאן כמה תמונות שנכנסות, כל אחת זה תוך איזושהי רשת. Hey, who's there? Hey, how are you? How is everyone? So actually here with my students, Hagai and Cheli, and they're telling me about their next idea for an AI project. AI is a field that experienced a major revolution about 5 years ago with the introduction of deep neural networks that have been able to solve problems that haven't been solved for many years, or at least showed a huge progress. The examples we all know are autonomous driving, Google beating the best player in the world in Go, or face recognition we see now in apps around us, or face deformation and so on. What we're actually doing here in the lab is branching off from this main stream of AI and working on data that comes from different sensors. I'm talking about medical imaging, ultrasound, depth cameras, three-dimensional scanners, and all these are basically producing a lot of data, and we want to adapt algorithm in order to analyze them in a smart way using AI. You consider this remote, for example. What makes you think that this is a remote? Maybe the way that the buttons are arranged on its front. So what we are actually trying to do is get a three-dimensional information, not just a picture, but think about a bunch of points floating in space representing this thing and making a computer understand what it is based on this geometrical information. So we have to pass from this very low level of information, which is just X, Y, Z points, to what it is. One application that we've been exploring for several years now is related to paleontology. So, you know, paleontologists dig up from the ground bones which have some distinct shape, and that's all there is, just a shape. There's no DNA attached to it and you cannot extract it. And the question is how, based only on the shape, you can actually classify species. Paleontologists have particular ways to interpret the shape of the bones and extract information. Having this ability takes a lot of training. Our goal was to teach a computer to recognize shapes of bones and then give this software to any novice user who can now do complicated analysis on bones without having this long training. So bones is just one example. These algorithms can then be used for any other things. If you think about like human organs, something like we're doing now with the human heart. Experienced doctor can say something about the heart just looking at a very noisy ultrasound image, and maybe the layman or you and me cannot do that. Our goal is to take his knowledge and pass it into a software that can be used by everyone. So the idea is knowledge dissemination in a sense. You know, we all saw these science fiction movies when we were kids, and you always wonder if that's ever going to happen. And I like being part of this journey.
Professor Yaron Lipman is one of many Weizmann researchers using AI to address the challenge of what is known as big data, the massive amount of information generated by today's advanced scientific technologies, which cannot be effectively or efficiently analyzed using conventional computer technology. At the heart of this effort is an exciting new tool called machine learning, where computers, much like the human brain, automatically learn and improve from experience without being explicitly programmed. From genome sequencing to medical data and high-energy physics, the new Artificial Intelligence Institute for Scientific Exploration will be home to Israel's most advanced computing infrastructure. The Weizmann Institute is a world leader in basic research, and this new initiative will give researchers something they have never had before, a dedicated on-campus entity where they can pioneer unique computer-based strategies, scale up human intelligence, quicken the pace of discovery to imagine the future.
Would you actually like to hear something about it in person? Okay, give me a minute, I'll be there.